It was the evening of June 9th, 1996. The passengers of Eastwind Airlines Flight 517 were looking forward to getting on the ground in Richmond, Virginia. Eastwind 517 was approaching the end of a flight from Trenton in New Jersey. In total, there were 53 passengers and crew on board the Boeing 737. Captain Brian Bishop and First Officer Spencer Griffin were commanding the plane, with the captain handling the flight controls. He prepares his aircraft for landing. It was a beautiful evening for flying, not a cloud in the sky. Captain Bishop was even flying by hand under visual flight rules, having disconnected the plane's autopilot as he approached Richmond. Both the captain and his first officer would later report that the flight had been smooth with no turbulence in the air. It looked like this was going to be a straightforward landing. Although, as the plane was descending through 5,000 feet, Captain Bishop felt something wasn't quite right. His rudder control appeared to be stuck. He would later tell investigators that he felt a brief kick and a bump in the rudder pedals, and he found the controls to be rather stiff. At the rear of the passenger cabin, a flight attendant hears a thump coming from somewhere within the walls of the plane. Back on the flight deck, the captain turns his head and glanced over to his first officer's feet to see if he was, by any chance, stepping on the rudder pedals. What does he see? The first officer's feet were flat on the floor of the cockpit. This only served to confuse the captain. He didn't know why, but his rudder controls felt stiff, almost as if they had locked up or jammed. At about 4,000 feet, before he could do much else to troubleshoot his rudder problem, Captain Brian Bishop would begin to experience a flight control upset induced from a design flaw hidden deep within the plane's tail. Control of the plane was seemingly ripped from the captain's grasp. The plane experienced an uncommanded roll to the right. To counter this, seeing his plane seem to take on a life of its own, the captain does what he can to bring his plane under control. He applies full left aileron. He almost steps out of his seat as he tries standing on the left rudder pedal to force it to go down. He even reduces power on the left engine to create a power differential. Slowly, the plane appears to come out of its uncommanded roll to the right. The captain even brings the plane through to a left bank around 10 to 15 degrees. Captain Bishop, though, knows the plane still wants to go to the right, but he was fighting it. In the cabin, flight attendants and passengers felt this movement of the plane, but before they could catch their breath, the plane once again suddenly rolls to the right. This oscillation greater than the last, as the plane rolls back through the neutral position into a steep right bank. Captain Bishop finds himself once again wrestling with the plane to bring it under control. The first officer pulls out the emergency checklist and reads that critical step: disengage yaw damper. Disconnecting the system, the plane appears to return to normal. Captain Bishop pulls the plane out of its erratic behavior. As if nothing had happened, he was able to safely land his plane in Richmond. Upon arriving at the gate, he picks up the passenger intercom but says nothing. He was left speechless. One passenger had sustained an injury in the event, but in the end, all 53 people on board walked away from the plane alive. They were very lucky. What the flight crew of Eastwind Airlines Flight 517 had managed to do was navigate a flight control issue that had been present on the Boeing 737 for years, and even contributed to 2 fatal accidents. In the early 1990s, a similar occurrence on 2 other Boeing 737s had claimed the lives of over 150 people. Other recorded problems on 737s spanning decades suggested a devastating mechanical failure was lurking within these planes. So what was it? Well, why don't we go back to 1991? United Airlines Flight 585 was nearing the end of a morning cross-country journey from Peoria, Illinois. After a stopover in Denver and a change of flight crew, the aircraft was only lightly filled for the very short 60-mile flight south to Colorado Springs. Just 20 passengers were left on board for this final leg. Among them was an off-duty United Airlines flight attendant heading home. Plus the crew, there were a total of 25 people on the plane. Up on the flight deck was 52-year-old Captain Harold Green. He was a man who some may call a by-the-book sort of captain. With over 10,000 flight hours to his name, he was known amongst his work colleagues to adhere strictly to standard procedures. He was joined on the flight deck that morning by his first officer, 42-year-old Patricia Eidson. Though less experienced with a total of 4,000 hours logged, she had flown with Captain Green before and the two got along well. Captain Green himself had even been known to give his seal of approval of First Officer Eidson's piloting, describing her as, quote, a very competent pilot. According to investigators, the performance of the flight crew as observed on the cockpit voice recorder suggested an expert flight crew that investigators later wouldn't fault. The plane the two pilots were flying that day was a 9-year-old Boeing 737-200. The specific aircraft was originally delivered to Frontier Airlines in 1982, before being transferred to United. By the time of the accident in 1991, the aircraft had racked up over 20,000 flight hours. The 737 family of planes are amongst the most popular in the entire world. If you've ever flown with Southwest or Ryanair, for example, you've definitely been on one of these things, and the plane is also flown by many other air carriers globally. It is, how you might say, the quintessential airplane. But if you have flown on a 737 in recent years, it probably didn't quite look like this. This is the 200 model, a smaller version of the plane that was developed all the way back in the 1960s. The plane has seen many upgrades since then. The 200 is certainly distinguishable amongst the lot with its smaller engines. It was one of the early models of the plane, and by the 1990s, Boeing had already launched the then next generation of the type, which came in the previous decade in the 1980s. But we'll have plenty of time to talk about the Boeing 737-300 later. It was a rather clear morning over Colorado on that fateful day in 1991. Visibility was reported to have been over 100 miles. At 9:30, the pilots tuned into the local ATIS at Colorado Springs to pick up the weather information. Winds appeared to be a bit gusty that morning, so the pilots added an extra 20 knots to their expected approach speed. The weather continued to be somewhat bumpy as the plane descended towards the airport. Proximity to the nearby Rocky Mountains can create a bit of turbulence for aircraft. Pilots are well aware of its presence, and it's not dangerous so long as they don't get too close. First Officer Eidson even gets on the radios to inquire about wind information from other planes in the area. She responds to reports of significant airspeed changes from other pilots with the words, "sounds adventurous," perhaps highlighting that they were still comfortable with continuing with the landing. They had done this before, and this was more of a case like, yeah, a bumpy landing, no problem. 9:40. The plane was on final approach into Colorado Springs. United Airlines Flight 585 was approaching from the south onto runway 35 using a visual approach, meaning the plane would be hand-flown. The conversation between the two pilots demonstrated how engaged they were in handling the aircraft. The captain going on record to note he was using more power from the engines to keep his airspeed. The winds in the area kept blowing against the aircraft, adding to that bumpy approach. Just a few miles from the runway, the pilots make one last turn to line the plane up for landing. As the aircraft flies through more patches of turbulence, the first officer commented one word: "Wow." It was the following moment, at 9:43 and 30 seconds in the morning, when a catastrophic failure reared itself in the back of the plane. Without warning, the plane yawed and rolled over to the right. Over the next 12 to 13 seconds, the pilots would fight to regain control of their plane. Ultimately, they would fail to do so. The plane had yawed so abruptly the plane rolled onto its back. The 737 inverted, and at such a low height of just a few hundred meters, there wasn't a whole lot of space and time to troubleshoot the problem. It was only a matter of seconds from the moment of failure to impact with the ground. The disaster unfolded right in front of the eyes of the airport controller and many local residents of the South Colorado Springs region. A multitude of witnesses on the ground observed the plane plummeting to its demise. The aircraft impacted the ground in a steep 80-degree nose-down attitude. The plane had just missed a complex of numerous apartment buildings. The place it actually crashed into was nearby Whitefield Park. The blast from the impact spread across the vicinity. At that moment of impact, an 8-year-old girl was standing in the hallway of her home, one of the nearby apartments. The blast had knocked her over where she sustained an injury to her head and required hospital attention, but she did thankfully recover. All 25 people on board the plane were killed. When Flight 585 impacted the ground, it left a crater 5 meters deep in a rather contained debris field, which would suggest to investigators that the plane had crashed whole with no in-flight breakup. Of course, for investigators, like in every case, they now needed to know what happened. However, as investigators proceeded with the investigation, they found themselves ruling out every possible lead they had. Engine failure? Not relevant. Pilot error? Not relevant. Maintenance? The aircraft had been dispatched with an inoperative APU, but that was not relevant. Weather? It was a bit bumpy. Turbulence? Did that really bring the plane down? It's worth highlighting that investigators in this case did explore a rather interesting possibility here in relation to turbulence. That perhaps there were similarities between Flight 585 and that of BOAC Flight 911. That accident, as we've discussed in a previous video, was the result of the accident plane, a Boeing 707, flying into a region of extreme turbulence in the region around Mount Fuji in Japan. The turbulence in that case had torn the plane apart. Considering the mountainous terrain of Colorado, it was speculated at the time that maybe something similar occurred here. If the plane had encountered mountain waves, which could leave behind rotors of violent air typically found in mountainous regions, it could perhaps, to investigators, explain why the pilots lost control of their plane. The problem is that according to the investigation, in their own words, there wasn't a whole lot known about this phenomenon, and they simply couldn't say that this was what happened. Boeing, though, did issue a public statement on what they believed was the probable cause for the accident, saying the weather was probably what brought the plane down. Here is NTSB investigator Ron Schleid delivering Boeing's statement on the matter at a board meeting in December 1992.
Boeing suggested the probable cause should be, and I'll quote, the airplane encounter with an unforecast and undetected high vorticity translating rotor near the ground in combination with a rapidly moving air mass which has been documented to have been in the area. This encounter at low altitude did not allow sufficient height for recovery. Close quote.
Investigators on the case weren't as quick to jump to that conclusion to say for sure that's what caused the accident. And rightfully so, because in retrospect, it's not correct. With little to work on at the time, investigators also focused on the only other plausible explanation for the loss of control, that being that there must have been a failure of the flight controls themselves. As you may already know, to allow a pilot to actually control their plane, they manipulate various control surfaces: ailerons on the wings, elevators on the horizontal stabilizer, and the rudder on the vertical stabilizer, the tailfin. Even despite the mystery that investigators were about to be presented with, they did correctly identify the source of the flight control failure stemming from the plane's rudder. Mind you, this was after combing over and examining numerous key pieces of wreckage. With attention on the rudder, they retrieved the mechanical devices that controlled it, and focus turned to a key servo valve component that helps drive the rudder movement. And don't worry, we'll be sure to become intimately familiar with this servo valve later in the video. However, much of the wreckage in this case was too badly damaged from a post-crash fire and from the impact itself to really draw clear answers from it. Investigators sent this servo valve for analysis with the manufacturer, where it was observed that tiny fragments of metal and other materials were found in the hydraulic fluid that runs through the valve, contributing to suspicions about a possible failure with this component. It was concluded, though, from the investigation's analysis, that this wasn't really related to how the plane crashed. As it turned out, though, the investigation did discover a history of rudder anomalies with not only this plane, but also other Boeing 737s. When talking about the accident plane, a number of write-ups related to the rudder mechanism were noted. For example, on February 25, 1991, 1 week before the crash, it was recorded that the rudder had unexpectedly deflected to the right, uncommanded. Another flight crew on February 27th also reported a similar occurrence. The pilots were able to retain control of the accident plane in those cases after switching off the plane's yaw damper. Despite this revelation, the NTSB, just like the mountain wave theory, weren't able to say from the evidence they had from the plane, from the evidence the accident had given them, that this was the cause of the accident. Examinations of wreckage from United 585's rudder were inconclusive. Basically, if there was a problem here, then it left no trace for investigators. The flight data recorder wasn't much help either. It was an older flight recorder and did not record flight control inputs, so investigators didn't have pilot input data, only certain flight parameters such as altitude, heading, and airspeed. After a lengthy investigation spanning 21 months, in December 1992, the National Transportation Safety Board published their first final report on the accident, with an undetermined conclusion. They arrived at two possible causes for the crash: the aforementioned weather phenomenon, or an unexpected mechanical failure, or some combination of the two. To quote the original 1992 NTSB report,
"The National Transportation Safety Board, after an exhaustive investigation effort, could not identify conclusive evidence to explain the loss of United Airlines Flight 585. The two most likely events that could have resulted in a sudden, uncontrollable lateral upset are a malfunction of the airplane's lateral or directional control system, or an encounter with an unusually severe atmospheric disturbance. Although anomalies were identified in the airplane's rudder control system, none would have produced a rudder movement that could not have been easily encountered by the airplane's lateral controls. The most likely atmospheric disturbance to produce an uncontrollable rolling moment was a rotor, a horizontal axis vortex, produced by a combination of high winds aloft and the mountainous terrain. Conditions were conducive to the formation of a rotor, and some witness observations support the existence of a rotor at or near the time and place of the accident. However, too little is known about the characteristics of such rotors to conclude decisively whether they were a factor in this accident."
For years following the release of this report, to many in the aviation industry, the media, and the flying public, the cause of the accident remained undetermined, with little developments in the case. But really, it feels like there's a whole lot more to the story. I mean, we did kind of glide over a lot in that segment. What about those anomalies with other 737 planes? What was all that about? Why does one of these reports detail an incident with a Boeing 747? What actually was going on here? Well, yeah, okay, there is more to this. More than what the usual narrative about the 737 rudder accidents leads on. I could have continued and moved on to talking about the USAir disaster and the investigation that continued into the Eastwind incident, but I just had to go and check. I just couldn't leave the stone unturned. And here's the thing. For me, I discovered a side of the story I had previously been unfamiliar with. I think, given the circumstances, I'd be doing a disservice if we didn't dissect the deeper depths of this. Let's delve into the depths of this chapter of aviation history and uncover the side of this that is often forgotten when these accidents are discussed. Documents that had been previously withheld throughout the 1990s but made their way into the hands of the public paint a much deeper narrative. Okay, we need to talk about the Boeing 737, its rudder, and the components of that system. The rudder controls yaw. It's one of the plane's axis of movement. If elevators control the vertical axis, pitch, and the ailerons control the roll axis, then the rudder controls yaw axis, a lateral plane of movement that is different from bank, which raises and lowers the wings. The first point of contact for a pilot when they want to manipulate the rudder is the rudder pedals. Just like in your car, there are controls in an airplane that are operated by use of your feet. The controls for the rudder and also typically the wheel brakes are located here. The system consists of two pedals, one for each foot, that, when pressed, actuate the mechanical system that moves the rudder left and right. On the Boeing 737 and most other planes really, the rudder pedals are connected to control cables that span the length of the aircraft to transfer the input from the pilot to the actuator system at the back of the plane. The rudder on the 737 itself consists of a singular large panel on the trailing edge of the tail fin, a design element the plane still retains to this day. The rudder deflects left and right to a maximum position of 26 degrees. Immediately connected to the rudder on the inside of the tail, it is connected to what is called the Power Control Unit, or PCU for short. The PCU receives inputs from the control cables and linkages that are connected to the pilot rudder pedals in the front of the plane. Within the Power Control Unit, there is a cylindrical subcomponent called the dual servo valve. This is the suspected valve we mentioned before. It's important to note that the servo valve and Power Control Unit terms should not be used interchangeably, but know that the servo valve is just part of the larger PCU system. Looking inside the dual servo valve, you'll find a primary and secondary slider that control the flow of hydraulic fluid. This then drives the PCU's actuator rod that physically moves the rudder. From researching this component, think of it this way. Normal rudder inputs allow the primary slider to extend and retract, opening flow ports for hydraulic fluid to flow and actuate the rudder. In times where a pilot may need to rapidly change the rudder, such as, say, flying through turbulence, the secondary slider can also move, providing additional pressure needed for that function. We need to make it clear that it's not only the pilot controls connected to this system. The valve can be operated without pilot input. This is because the plane's yaw damper is also connected to this servo valve. The yaw damper, in simple terms, is a tool that can make flying more comfortable. It's like a stabilizing system to automatically compensate for lateral movement in the air. The yaw damper can send an electrical signal to the rudder power control unit and command the valve as needed. Because of this, the PCU is almost in constant use throughout a flight, adjusting the rudder. When Boeing designed the plane, they outsourced the manufacturing of the power control unit to a company called Parker Hannifin. Parker Hannifin contracted with Boeing to make plane parts for multiple Boeing aircraft. It's this component, their servo valve. This is our culprit. Now, it's here where things get a bit more complicated, and it's here where the topic of this video really begins to spiral out of control. Problems related to the Boeing 737's rudder mechanics date all the way back to the 1960s. In a 1999 document that was published in reflection of this whole fiasco, it is summarized that air carriers and Boeing knew of, quote, anomalies in the 737's rudder for around 30 years. Occasional uncommanded yaw vents and locking of the rudder have been documented, and some of these even made their way into the subsequent accident reports, but it hadn't been suspected in a fatal accident until 1991 in Colorado Springs. During the investigation into United 585, another incident took place in July 1992 in Chicago. This became known, by those who've actually looked into it, as the Mac Moore incident, named after the pilot, Captain Mac Moore. Interestingly, Captain Moore was a bit of a legend amongst United Airlines pilots, and was even involved in the investigation into United 585. He was a representative for the Airline Pilots Association, present when the cockpit voice recording was played back. Captain Moore was also a man of the opinion that there was a major flaw hidden within the plane's flight controls. It's quite fitting then that he would play a major role in further exposing that fatal flaw. On July 16, 1992, as he was taxiing out to the runway in Chicago, he was in the middle of performing pre-flight flight control checks on his Boeing 737. He happened to notice a problem with the plane's rudder. Movement of the pedals felt stiff and sluggish, almost as if they had jammed. He requested a return to the gate, and a private investigation was launched between United Airlines, Boeing, and Parker Hannifin, the manufacturer of the power control unit. The PCU was then removed from the plane and taken to California to undergo testing at a United Airlines facility in San Francisco. This was shortly followed by a trip to Parker Hannifin headquarters in Irvine. It was during this time that the PCU was extensively tested, and they were able to observe and replicate anomalous conditions in its mechanisms. During testing, it was observed that the sliders inside the dual servo valve could catch against one another and against the servo housing itself, effectively creating a jam. What could happen if we go back to the diagram is that a jam of the secondary slider against the servo housing could allow the sliders to configure into a false state, leaving the hydraulic fluid ports misaligned, and when that happens, fluid flows incorrectly. This can even result in a leakage of hydraulic fluid, something that was believed to have occurred in the case of Flight 585. What we then get is a command to move the rudder to the extremity position in the opposite direction, forcing the rudder into what we call a hardover. If that wasn't bad enough, hydraulic fluid in the scenario could flow in the reversed direction to what was commanded. What had been observed here was a rudder reversal event. If a pilot was to encounter a reversed rudder like this, it would effectively mean their rudder controls were mirrored. For example, if a plane experienced rudder hardover to the right, as the pilot tries to put their foot down on the left rudder pedal to correct it, a rudder reversal scenario would prevent this. This whole condition induced by this fatal design flaw is what was at the center of this whole fiasco. This was what brought United Airlines Flight 585 down. This is what killed those people at Colorado Springs that morning. Captain Green and First Officer Eidson were, without warning, forced into a rudder reversal scenario whilst at low speed, low altitude, leaving them vulnerable to a lateral upset like this. They were never trained for it. They had no idea what had even happened. A report that details this private testing of the valve suggested that tapping the mechanism could jostle it free and it could return to normal. Unfortunately, it didn't when it took those lives, and the pilots weren't able to recover from the mess it had left them in. The report I'm referring to, by the way, is actually the original NTSB report into the United 585 disaster. The report closes the segment with mentioning Boeing and Parker Hannifin were developing changes to the design of the dual servo valve. So, the cause of the crash was actually known at the time. However, from what was presented to investigators in the plane's wreckage, they couldn't make the connection. Now, the NTSB was not actually part of this private investigation, as I've called it. So how did they become aware of this? So United Airlines, Boeing, and Parker Hannifin conducted this investigating for about 3 weeks, whilst withholding information from the NTSB. So United Airlines was, at that time in 1992, now involved in an additional investigation to try and find out what was happening with these planes, whilst they were a part of the NTSB's investigation into their lost plane at Colorado Springs. This evidently was not appreciated by the NTSB. We know this because when investigators did find this out a month later, they sent an official letter of reprimand to United Airlines expressing their disapproval of conducting this investigating without disclosing it with them. The investigation in this letter confirms that simulation testing showed that a rudder hardover could lead to a loss of control and could have led to this accident. This is followed up with, quote, "In my opinion, for United Airlines to unilaterally decide that the information related to the case involving ship number 1394, that's the McMoore unit they did testing on, for them to decide that information is irrelevant to United 585 without notifying the safety board is not in compliance with the team concept for a major investigation." In a further document, a formal acknowledgement of the design flaw from the NTSB confirms they had now been made aware of this information. Concern about this design flaw grew as, for a time, it became suspect in the crash of a Boeing 737 from a Panamanian airline in 1992, although this accident turned out to be unrelated. But going back to that letter of reprimand for just a second, I couldn't help but notice this point here. Quote, "Because United Airlines had decided to evaluate it before someone overreacted, he said that there have been many United Airlines pilots and mechanics that had reported solving Flight 585. Yeah, so there is a deeper layer here that suggests that actually, mechanics on Boeing 737s had known even earlier than 1992 about the design flaw. In August 1991, just a few months after the loss of United 585, an aircraft mechanic in California by the name of Wayne Gallimore wrote a letter of concern to another mechanic in Ohio by the name of Don Pomerico. Pomarico was a union delegate at the International Association of Machinists and Aerospace Workers. In this letter, Gallimore goes into detail about a conversation he had with United Airlines mechanics regarding the culprit servo valve recovered from United 585. It is explained that United Airlines mechanics were concerned about the state of the component recovered from the plane and had suspected a rudder hardover scenario. Here is what the letter contained.
Dear Don, I recently had a conversation with the mechanics at United Airlines hydraulic shop, which has caused me concern. These are the same mechanics that participated in the component disassembly of the units taken from Flight 585. In every sense of the word, they are experts. During the disassembly of the rudder hydraulic power units taken from Flight 585, the primary control slide was found jammed in the secondary control slide on the rudder hydraulic power unit control servo. The primary slide moves inside the secondary slide, and the secondary slide moves inside the servo body. At no time should there be metal-to-metal contact between the slides or servo body. It was assumed that impact damage had caused the primary slide to jam inside the secondary slide, even though the secondary slide was not jammed in the servo body. Nor was there evidence or direct impact damage. In fact, no other part of the rudder hydraulic power unit was jammed. The unit had sustained fire damage and the piston rod was exposed and bent, but internally it disassembled normally, except for the secondary slide. After forcing the primary slide off the flat surface of the secondary slide, the primary slide operated normally inside the secondary slide. It should be remembered that the aircraft had several write-ups on the yaw damper prior to the accident. To my knowledge, no positive reason for these write-ups have been found.
As further detailed in this letter, Gallimore drew attention to yet another 737 rudder incident also in Chicago, but one that occurred during the climb-out phase. An investigation there reportedly revealed further contact between the critical sliders. Gallimore posed questions for consideration to the National Transportation Safety Board, basically asking, will a jammed slider in the dual servo valve cause rudder hardover, and can that lead to loss of control? Of course, we now know with hindsight that the answer here was yes. Mr. Gallimore closes the letter saying, I believe it is imperative that the NTSB be notified and a complete investigation be done immediately. All of this is to say that the fatal problem with the Boeing 737's rudder had been discovered. There were mechanics and engineers in the aviation industry and within Boeing at the time who were aware of this, and they were trying to fix it. This became the subject of a crucial meeting within the Boeing company in 1992. The meeting was called hot off the heels of the then recent investigation into the Chicago incident, the McMoore incident, of July of that year. The subject of the meeting was to discuss a possible retrofit for all Boeing 737s to fix this issue, and to devise a plan to present this idea to Boeing VPs. The notes about this meeting are rather front about the matter. The use of the blunt phrase, "we have a problem," stands out, as does "valve doesn't meet fail-safe design intent," and "single valve jam gives potential for reversal." However, despite this urgent wording, it's clearly stated that they didn't need to ground the fleet, but they did need a retrofit program to conclusively fix the problem. A number of retrofit options were presented within Boeing to fix the issue in October of 1992, and wait, hold on. October 1992? Wait a minute!
Boeing suggested the probable cause should be, and I'll quote, the airplane encounter with an unforecast and undetected high vorticity translating rotor near the ground in combination with a rapidly moving air mass which has been documented to have been in the area.
You know, it really begins to feel like, from all that we've looked at here today, that Boeing, Parker-Hannifin, and United Airlines were trying to get ahead of the curve a little bit, to be all like, oh, this? No, that's not related to this. That was actually the weather. We have a saying where I'm from to describe something like this. It's called taking the piss. A number of retrofit options were presented within Boeing to fix the issue in October 1992, and these options ranged from doing nothing up to a costly replacement program for Boeing and Parker-Hannifin. What the results of this meeting were and what Boeing ultimately settled on doing was progressing with a long-term plan to retrofit the units. This also happened to be the least costly option short of not doing anything at all. So let me get this straight. Boeing released a statement saying the probable cause into Flight 585 should be the weather, even though investigators had also been suspecting rudder failure, which is something that their guys had been investigating themselves, found a relevant link to just weeks ago, and just had a meeting about replacing the relevant parts. Were they just not seeing the connection there? The frustrating conclusion that I arrived at during research of this video is that if immediate, appropriate action was taken here in 1992 to retrofit and replace the fault on Boeing 737s, what comes after in this story could have been avoided. It wouldn't be until the year 1997 when an airworthiness directive was issued that forced Boeing and airlines to commit to replacing the parts. This whole situation was only made more devastating when it happened for a second time, because this all went down 2 years before the second disaster. But before we get there, we need to turn our attention to the other side of the Atlantic Ocean, because a whole separate investigation involving Parker Hannifin's servo valve components was about to take place. As it turned out, this sort of problem wasn't just limited to the Boeing 737. October 7th, 1993, London Heathrow, United Kingdom. The Boeing 747-400, registered as Golf Bravo November Lima Yankee, was about to depart on an overnight flight to Bangkok. As the pilots of this aircraft took the plane into the air, something rather unusual occurred with their flight controls. Normally, the pilots would have to keep their nose raised as they climbed out of the airport. However, as the large jet was just 100 feet off the ground, so almost immediately after takeoff, the pilots experienced an uncommanded change of the plane's pitch. There was an abrupt downward shift from 14 degrees nose up down to 8 degrees, completely uncommanded, catching the pilots by surprise. The pilots acted quickly and were able to retain control of their plane and actually continued their flight all the way to Bangkok, where they landed without incident. But this event didn't go unnoticed. The British Air Accident Investigation Branch was notified and launched an investigation. It should be noted here that there are key differences between this rather minor incident and those involving the Boeing 737. The 747 is a completely different plane. The key component of interest here, though, was the power control unit involved with the movement of the right elevator. Seemingly uncommanded, the right elevator over-traveled into a down position. It would take British investigators over a year themselves to find out what happened in this case. Meanwhile, during this investigation, further disaster would strike in the United States. It was the early evening of September 8, 1994. USAir Flight 427 was en route back to its base in Pittsburgh. Having flown from Chicago, the flight crew of this Boeing 737 was nearing the end of their flight. Flight 427 was set to continue on that evening down to Palm Beach in Florida. At the flight controls was 45-year-old Captain Peter Germano. Considered to be an excellent pilot, he was hired by USAir back in the early 1980s, where he previously flew for Braniff International. By this time, he had acquired about 12,000 total flight hours, 400 of which were in the Boeing 737. His first officer, 38-year-old Chuck Emmett, was also a hire from a previous airline. He was merged into USAir as he originally began flying for Piedmont Airlines in 1987. Like his captain, he was regarded as a highly skilled pilot with over 9,000 hours logged. The two pilots were approaching the end of a 3-day flight trip. In the cabin were 127 passengers and a further 3 flight attendants, bringing the total number of occupants on Flight 427 to 132. Though this aircraft was a Boeing 737, it actually differs from the other 737 planes used in those other cases of United 585 and the later Eastwind 517 incident, which we touched on in the intro of this video. The Boeing 737, as you know, is more than just one plane, it's a whole family of them, with different subfamilies or generations of 737. The early models, the 100 and 200, were the original models. The second generation 737 was later dubbed the 737 Classic, consisting of the 300, 400, and 500 models. These planes launched in the 1980s. In the 90s, Boeing launched the next generation models, the 600, 700, 800, and 900 variants, with the MAX being the latest generation of the plane, launching in the 2010s. This particular plane involved in the accident of Flight 427 was a 300 model, so it falls into the Classic family. November 513 Alpha Uniform was delivered to USAir New in 1987. When Boeing designed the then newer Classic generation of the plane, though there were many key changes such as a major upgrade to the plane's engines, they still retained many of the original design elements and reused many components, including the tail and the power control unit. Without really knowing what the problem was at the time, Boeing had effectively brought the rudder issue over to this newer plane in the 1980s. Of course, the pilots of Flight 427 knew nothing of this. They had no idea that lurking in the tail of their plane, disaster was about to strike. Back in the flight deck, it was the first officer handling the flight controls on this journey. Captain Germano was on radio communications. The time was 6:45 in the evening when the pilots first began their descent to their destination in Pittsburgh. Descending from their cruising altitude of 29,000 feet, the pilots routinely checked in with controllers as they navigated the busy airspace of the American Northeast. The atmosphere on the flight deck was calm, as was the sky outside. The pilots were at ease. A flight attendant even entered the cockpit and asked if they'd like a drink before landing. 6:54. USAir Flight 427 receives instructions from air traffic control to descend down to 10,000 feet and slow their airspeed. Flight 427 was given a set of approach instructions to land in from the east onto runway 28 right. Flying from Chicago, this meant a small delay as the plane needed to fly east of the airport to line up on their approach heading. Not only that, but Pittsburgh airspace was also rather busy that evening, and another flight was sequenced ahead of Flight 427. A Delta Airlines Boeing 727 was also en route into Pittsburgh and, got there before USAir 427 did. Air traffic control and the USAir flight crew did successfully manage their spacing and airspeed to accommodate this busy time. USAir 427 kept about 4 miles behind the Delta plane. But what this did mean was that the pilots were looking out for the traffic and also needed to pass through the wake turbulence left behind by the Boeing 727. At precisely 7:03, as the plane was heading out in this easterly direction, Captain Germano and First Officer Emmett bring the plane into the wake turbulence. It's bumpy as the plane flies through it. The pilots tried to keep the plane level. There was an initial roll to the left, but this was briefly corrected. The cockpit voice recorder then picks up remarks by the pilots as they entered the expected turbulence, followed by a series of thumps, which were believed to have been related to the wake turbulence. The first officer takes over control of the plane from the autopilot. However, as he holds the plane in his hands, the aircraft suddenly yaws hard to the left. As the pilots lose control of the aircraft, it overbanks into an inverted position through the left roll. Unbeknownst to the pilots, the plane's rudder servo valve had malfunctioned, inducing a hardover and reversal event. They had no idea how to stop it, and they had just seconds to act. Applying all the strength he could, First Officer Chuck Emmett still couldn't pull the plane out of its erratic dive. At exactly 7:03 and 23 seconds in the evening, the Boeing 737 with 132 people on board crashes into the Pennsylvania countryside, leaving no survivors. The impact left the plane completely destroyed, just like in the case of United 585. The plane had crashed in an extreme nose-down attitude, obliterating the plane on impact. The scene was so disastrous that investigators required full biohazard equipment to begin their work. Around 6,000 individual human remains were recovered from the site. The investigation into this case did have additional leads this time around. The tail section was relatively intact, leaving the tail's power control unit in better condition, allowing for further testing. In addition, the plane's flight data recorder did record more information than the United aircraft. However, investigators were still left disappointed with how long the intervals were between when the flight recorder recorded flight control inputs. So they did have flight control data, but it wasn't as precise as they would have liked. The flight data recorder was able to be interpreted though, and the NTSB released this animation of the crash sequence, showing just how little time there was between the upset occurring and the crash into the ground. Revisiting United 585, investigators were able to compare the two accidents with remarkable similarities between the two. They were able to see where the United plane yawed and rolled to the right, the USAir plane did so to the left. Both sets of flight crews were highly experienced, and both seemed to be caught off guard with a situation they had never seen before. Considering the weather conditions in the USAir case were clear and calm, weather was ruled out in the case of United 585. There was no doubt the two accidents were linked. With the rudder now the prime suspect in both accidents, investigators sought to test the power control unit from the USAir plane. Disappointingly, like in the United case, this yielded inconclusive results. Boeing around this time decided to produce another theory of their own, that being that the pilots had inadvertently stomped on the wrong rudder pedals, leading to loss of control. Certainly a hot take, you could say, especially when you consider that the rudder issue was evidently known within the company. Investigators were able to find that the pilot flying did make a crucial error in their flight control inputs. The first officer, during the unfolding crisis, aggravated the bank of the plane by pulling back on the control wheel. This led to an aerodynamic stall just before the plane crashed. USAir and pilots' unions were staunchly against the theory put forward by Boeing and were of the correct belief that this was a case of mechanical failure. The NTSB would also later mention that the pilots were never trained to deal with this scenario, and with such little time before the plane crashed, they deemed recovery to be pretty much impossible in this case. Investigators were still at an impasse. Though they were aware of the potential for rudder hardover and reversal to occur given the other previous noted incidents, they could not find the evidence amongst the wreckage of the two planes that had actually crashed to say it was the cause. In December 1994, whilst the USAir investigation was ongoing, the investigation into the incident at Heathrow was drawing to a close. The Air Accident Investigation Branch released their report into the matter, and this was their conclusion.
The secondary slide of the servo valve of the inboard elevator power control unit, or PCU, is capable of over-traveling to the internal retract stop. With the primary slide moved to the limit imposed by the extend linkage stop, the four chambers of the actuator were all connected to both hydraulic supply, and in return, the servo valve was in full crossflow, resulting in uncommanded full-down travel of the right elevators. A change to the hydraulic pipework associated with the right inboard elevator power control unit was implemented on the Boeing 747-400 series aircraft without appreciation of the impact that this could have on the performance of the unit and consequently on the performance of the elevator system, and that it could exploit the vulnerability of the servo valve.
This sounds rather familiar. It appears that an over-traveling of the servo sliders led to misaligned flow ports, resulting in a false setting, ultimately leading to an uncommanded action on the flight controls. It looks like the same severe design flaw had jumped to another plane. The same suspected parts in the 747 incident were also manufactured by Parker Hannifin. They were similar to the ones used in the 737's rudder mechanics. The British investigators even contacted the Federal Aviation Administration in the United States to be all like, hey, you better look at this, requesting they look into whether the PCUs manufactured by the same company can induce similar flight control problems on the Boeing 737. As a result of the findings in this case, Boeing made changes to the elevator actuator system and retrofitted this on all Boeing 747-400s. As the investigation into USAir 427 continued into 1996, the Eastwind incident took place. This was another breakthrough in the investigation. After Captain Brian Bishop successfully landed his plane in Richmond that evening, investigators now had a plane fully intact, but they also had living pilots, who were able to confirm that their rudder appeared to be jammed, as if their pedals were working against them. The faulty aircraft stayed in Richmond until investigators got there. No one touched the thing. When investigators got to the plane, they They pulled out its rudder power control unit and, disappointingly, found it to be working normally. Even after flight testing the thing, investigators came up short, despite this plane clearly having something wrong with its rudder, as further backed up by the living captain. The NTSB now had numerous power control units to play with. They tested parts from United 585, USAir 427, Eastwind 517, and they even had a brand new power control unit available to them. Further testing on all of these units, however, still yielded poor results. They couldn't get any of them to produce the anomalous conditions that were suspected in the two crashes. Investigators tried a different approach. They re-evaluated the USAir wreckage and performed a thermal shock test on the servo components. They put the component through rigorous environments with the idea that it would emulate flight conditions. After cooling the device and pumping it with heated hydraulic fluid, finally they caught a break. The dual servo valve jammed right in front of the investigators' eyes for the first time. However, there is a key thing to bear in mind here. There is no evidence to suggest the thermal differentials can influence the jamming, and the accident report even states, quote, "The extreme temperature differential produced during this test condition would not be expected during normal flight operations." But it had been observed, though, in comparison to the USAir PCU, the newly produced components that Boeing began rolling out around this time performed normally during the same test. What this was able to demonstrate, though, was the Boeing 737's rudder servo component could malfunction if the conditions were right. Boeing was able to confirm from the investigation's findings that a rudder reversal event had occurred here. It was now the belief of investigators, it only took them several years, but still, that in all three incidents, United 585, USAir 427, and Eastwind 517, the secondary slider inside the dual servo valve jammed against the servo housing, enabling the primary slider to overtravel. From this, the hydraulic fluid ports could become misaligned, inducing a reversal event. So the flight crews of the accident flights not only experienced a jammed hard-over rudder, but also experienced reversal. Not knowing this was the case and thinking they were trying to correct their flight control problem, they only made it worse. As a result, over 150 people lost their lives. And with one final note, where the two disasters differ from the other string of incidents, were that they occurred during a phase of the flight where the rudder malfunction could greatly influence the roll axis. After a lengthy investigation spanning 4 years, the National Transportation Safety Board published their final report on Flight 427 with these findings in 1999, with a revised report into Flight 585 coming in 2001. The Federal Aviation Administration ordered Boeing to replace all of the units on 737s by the end of 2002. New pilot training was introduced that tells pilots how to recover from rudder anomalies. It didn't have to be this way. Boeing knew there was a problem that needed addressing after the first accident. The issue wasn't fixed, and Boeing 737s continued to fly for years after with this fatal design flaw, and a second plane crashed. However, the problem has now been fixed. In the years since, the power control unit has been redesigned and replaced on all 737s, a process that continued into the 2000s. The Boeing 737 family of airplanes continues to fly millions of people every year, and all things considered, is one of the safest planes in the sky. There has never been another accident like this again, and this chapter of aviation history was brought to a close. To conclude this video, why don't we end with some additional notes regarding two of the planes we've talked about in this video. Both the British Airways Boeing 747, Golf Bravo November Lima Yankee, and the Eastwind Boeing 737, November 221 Uniform Sierra, both of these planes had managed in different ways to get themselves involved in further incidents. Following its notable incident, the Eastwind plane returned to service with the airline. About a month later, the pilot flying the plane in the evening of July 17, 1996, reported witnessing the demise of Transworld Airlines Flight 800. In our own video on that fateful evening, if you recall, we looked at the ATC recording that was released after the disaster. That pilot communicating with ATC with regards to Flight 800 was flying that same plane that Captain Bishop landed that evening in Richmond. On April 28, 2000, the British Airways Boeing 747 was involved in, quote, a serious incident as described in the report. In a mishap at London Heathrow Airport, the massive plane, just as it was about to land, nearly crashed into a British Midland Airbus A320 that was holding on the same runway. Controllers ordered the pilots of the British Airways plane to abort their landing. They avoided disaster with just over 100 feet of space between the two planes. If things had played out differently, up to 450 people could have lost their lives. Hello everyone. I really did not expect this video of all videos to be as long as it is. There was no way I could have done a video about this and not gone deeper into it. I started researching this late last year and I put it on hold until I had more time. This subject, though, has been non-stop on my mind for the last month. I've lost sleep trying to piece this one together. Anyway, we got it in a video. I hope you liked this one. If you did, be sure to be subscribed so that you don't miss out on what comes next. I think now that I've put this video behind me, I might go back and finish a rail disaster video I had also started late last year and again put on hold for more time. Anyway, it is that time where I must take a moment to thank my amazing patrons over on Patreon who have continued their support to the channel. The support on the Patreon these past 3 weeks has been insane. We actually just hit 200 patrons, which is unbelievable. We've had a ton of new Patreon members and I couldn't be more thankful. There were plenty of new joiners at the £3 tier, so hopefully they are all on the scrolling list that should be on the screen right now. So, shoutouts today, we've got a bunch of them. So, starting with the £5 tier, in order of which they joined, thank you to Musafa, Sebastian Rodriguez, Silk Kana, Veronica Fox, and Disguised. Thank you all so very much. Big thank you to those who pledged at the highest tier. Big thanks go out to Colin Jones. They actually increased their pledge, so massive legend. And also we've got Jacqueline Nutton. Thank you so much. Legends. Total legends. If you yourself would like to support the channel further, you can join the Disaster Breakdown Patreon from just £1 per month, and the link to that will be in the pinned comment below. All patrons get early access to all new videos 2 days before they go out publicly on YouTube. Anyway, we got it in a video, and big thanks to Plainly Difficult here on YouTube for lending their voice for that segment. I really do appreciate that. I'll leave a link to their channel in the pinned comment below, so go check that out if you haven't already. That is all from me today. If you'd like to catch me on Twitter, that too will be linked in the pinned comment. Other than that, thank you all so much for watching, and I shall see you next time. Goodbye!